Hello. So I've started rolling this a minute or two early just to make sure that everything is hunky dory with the stream. This is my first stream direct to YouTube officially. So I just want to make sure. Yeah, it looks like we're good. Looks like we have sound. So let's get cracking. So the title card said software projects IT inventory. Hubba. Certainly there are products out there, commercial products out there for doing IT inventory, maintaining details about hosts that are in an environment. Some of them are sophisticated, some of them are not. Some of them are tuned toward a particular brand or software or hardware platform like Mac or Microsoft. And I just, my fleet of machines is not set up that way. And, you know, one of the things that I wanted to be able to do is capture, model, serial number, if any, and MAC addresses. Because in some circumstances, like for instance, if you've got to do warranty stuff, you're going to need the make, model, and serial number. And if you're doing any kind of network troubleshooting, it's very handy to have the MAC address of the host to see if it's, for example, DHCP has issued it a lease, and for whatever reason, maybe the host name doesn't show up. But you should be able to track it by the MAC address. Or if you need to, set up DHCP to have the MAC address there without having to log into the machine or open it up and find a label somewhere that has the MAC address. Simplifies, streamlines things quite a bit. Now, a big chunk of my computing fleet now is made up of Raspberry Pis. Raspberry Pis, as far as I've been able to tell, and I suppose I could look a little deeper, but I haven't seen serial numbers on them. You know what? While we're here, here's one I prepared earlier. I could probably see if I had glasses. I had glasses. Oh, damn it. I got an itch right where I can't reach it because my shoulder's all messed up. Darn it, I had glasses. Well, there's certainly nothing screen printed on here with a serial number. There is... Here's a check to see if this thing will focus. That little label on the bottom of the Raspberry Pi might be a serial number, but I don't know. It may just be a batch or lot number. It's hard to be sure. But in any event, like on a Raspberry Pi 3B Plus or a Raspberry Pi 4, the 400, there's no indication that I can see of where the MAC addresses are printed or anything like that. So you have to log into the machine. You have to start the machine, log into the machine, and look at the network information to get the MAC address. So anyway, what I had been doing is using a Brother P-Touch label maker to to make labels to put on the thing so that I could say, this is the host name, this is the serial number, this is the MAC address, this is the model number, because a lot of times, like, let's not knock anything over there. Just a moment. So, this little laptop is a Lenovo IdeaPad. Yeah. Okay, it's an 11-inch dual-core Atom, I think, or Celeron. And I bought it as a throwaway when I was commuting to Boston on the train every day. I wanted to have a laptop that I could do software development on. Nothing super duper sophisticated, but, I was writing Python and JavaScript for a web app that I was working on. And, excuse me. And my previous throwaway laptop had a bad day. It was a Dell Inspiron 11-inch. It was basically Dell's version of this, and I had bought it as an open box for $150 at Best Buy. Immediately installed Linux on it. And so they didn't have any of those. So I got this. And so as far as models go, let's see if I can show you this. So there it says 110S. All right, well, that's interesting. But if you look at the bottom, will it focus? Will it blend? So you see that model there? It's got a bunch of extra characters on it. If you have to get parts or warranty service on this sort of a thing, that's the information you're going to need. When you're looking up repair videos or whatever, that's the information you're going to need. And of course, the serial number's on the bottom. Now, if you've got the laptop and you're doing the things, you can't see that I'm doing these things. But if you have the laptop open like this and you're doing the things, it's very difficult to then go, oh yes, this serial number is blah, blah, blah. Right? So having a label like that is handy. It's got the host name, it's got the model and serial number, and the MAC address for the one Wi-Fi interface. So that was the goal of this, is to be able to build up a library of information on the various machines that I have around all over the place, and be able to print these labels readily without having to hand type every time I need a new label. Now, I had bought some time ago a Brother. Is it Brother? Yeah, it's Brother. XL QL 700 label printer, and you can do like address labels and a variety of other kinds of sticky label printing on it, but it's USB connected to a computer. Now, when I had initially bought this thing, the only software that they had available for it was for a Mac. And of course, it's this, okay, here's a template, and you can fill in fields on a template. And I was just like, no, that's hot garbage. Doing any kind of programmatic formatting to use with this software is just garbage. And Mac makes me sad. So I decided, all right, someday maybe they'll come out with a Linux printer driver. Well, they did. Not only is there a Linux printer driver for this thing, but they have drivers for several different flavors of Linux. So they actually have a separate driver for Raspberry Pi OS, which is fantastic because using a printer, a Raspberry Pi as a print server is great because it's low power consumption. You can do all kinds of extra USB stuff if you're using a Raspberry Pi 3 or 4. You've got an Ethernet connector, so you've got, an always on connection that's not going to be interfering with or interfered with by being on the same collision domain as your Netflixing or whatever the hell else you're doing. Is just a great option. So I downloaded the driver for the Raspberry Pi OS and installed it and hooked up the printer, and freaking magic. And just using regular LPR, right? You don't have to do anything extraordinary by building out bit streams and sending it out a particular USB device. It registers in cups, just piece of cake. So that was great. So if you're looking for a label printer to use with Linux, pardon me, the Brother QL700, which I think is still available. There wasn't any indication on the site, on the Brother site. Let's see, Brother, not Ruther, Brother, QL700 printer. Yep. So, hold on a second. Let me do that, and then I will do that. So that's the baby right there. That's the Brother QL700, and they're still for sale. And there's a variety of widths of labels that you can get to go with that. So that I would recommend. For this or for any variety of other applications that you might be considering. So let me see if I can get that back over here. All right. So what's next? Do I want to hand write the information that's going to go on the labels? No, I don't. I wanted to be able to have a store of data and then select which pieces of that data I want to appear on a label and print a label. So basically what I decided to do was to write a little application in Python. And right now it's kind of in a early development stage. I've worked on it for about a day and a half, like 12 hours. And it's not huge, and it doesn't do a lot of validation in it. But let's do a quick demo. I'll show you what it does, and then I'll show you what's in it. So let's go back over here, and let me do that so we can see. That's great. So the working name for it is SysTouch. Oh, whatever. It's something that popped into my head. There's two files. There's SysTouch data.json, and that is the data that's stored. It's a base64 encoded JSON data structure to kind of condense the file size a little bit and make it more readily transportable. Like, for instance, if you're going to send the file to somebody, there's not a bunch of, braces and shit in there that's going to make some interpreting step sad. So base64 encoding is pretty safe for without any further encapsulation. You can send it over a network. And systouch sketch.py is the Python file, the actual program. So if I am in here and I say systouch sketch.py, and it gives me a main menu. And there's a few things in here that we can do. We can add a host. And again, this is all local to the machine. This is all local to the machine. There's no connection to an external database or anything like that. There's no APIs right now. It's just very old school. You have a program, you have a data file locally on your machine, and there's a conversation, and that's it. So we can add a host, we can modify a host, we can remove a host. Actually, remove host doesn't work yet. We can print a label, which doesn't actually print a label. It displays the content for the label in plain text. So there's an extra step. It's kind of a pain in the neck, but it works for now. Display list of hosts, display details of a host, and quit. So add a host is pretty straightforward. It just asks you a series of questions. So if I say one, and I'm going to call this fake host, and host function is paperweight, virtual machine, no, asset tag. Now, as I said, there's no validation on this. You can just hit enter, and that leaves the value of 0. Ooh, excuse me. Enter host comment. I have no comment at this time. Okay. So who's the manufacturer of the OS? Let's say Macro Bloat. And we're going to call this Wind Blows. And the version of the OS is E. And the build of the OS, we don't have one. Serial number, none. Product key is nothing. Okay, so if you're familiar with Python, which I'm hoping you are, but there's a possibility you're not. But most modern high-level programming languages have compound data structures, right? So in Python, the two most popular compound data structures, as far as I know, are the dict, or dictionary, and the list. So a list corresponds to an array in most other programming languages. It's an ordered list of elements. And a dictionary corresponds to an object in most other languages. The dictionary consists of key-value pairs. The thing about a dictionary in Python, and I think in most other languages, the order of the key-value pair in the structure can change. It's not static, and so that can cause some confusion. Fortunately, you have a method on the dictionary class called keys. And so what you can do is just get the list of keys off as a list, or an ordered list, or an array. And so all of that is preamble to say that in here, let's see. So the host details and the operating system details, those are both dictionaries, right? It's a single set of key value pairs. The hardware, and as we'll see later, the network interfaces, are a list of dictionaries. So there's a definition of the dictionary that contains the attributes for a hardware item or a network interface, which you can have multiples of those in the list. So for this, like typically what I would say is we would do the either the box in the case of a store bought, like a laptop or something like that, the outermost machine. But if you were doing something like a home built machine, right? So you bought a motherboard, you bought a CPU, you bought RAM, you bought a display card, you bought SSDs and all this other kind of stuff, and everything's got a serial number and everything's got a model and everything's got a manufacturer. It would be handy to be able to say at any time, provided your database is valid and reachable, to be able to say, okay, I need to know what the model and serial number of the video card is because stupid warranty issue. Well, if you can just hop into your little database, you can dig that up and be much happier. So that's kind of the idea there. And the thing with network interfaces is you don't know how many network interfaces a machine might have. I mean, you could have let's just say, for the sake of argument, you've got goodness gracious, you've got a Cisco router in your rack, and it's got 5 network interfaces, 5 distinct network interfaces, not just a switch. But, oh, well, gosh golly, you want to keep all the information on all of those interfaces. So, you can do that because there's the details for a network interface, and you just create another one in the list. So, let's create a hardware item. Let's say, manufacture the hardware item. Let's say, dude, you're getting a Dell, and the model is Poopsperon, and the serial number of the hardware is that, and the version of the hardware we don't know. Comment. Dude, you got it. Add another. No. Network interfaces, yes. Now, the thing here is, not every machine that you might want to have in your inventory necessarily has a network interface. For example, let's just say, for the sake of argument, you're a retro community guy and you've got a VT100 terminal. Well, you want to keep track of it for some reason, but it doesn't have a NIC because it's strictly serial, right? Well, that's a thing. But in this case, we'll go ahead and say yes. And we'll call it ETH0. And the hardware address is, let's see if I can. Okay, so that's 6 octets. And again, there's no checking on this at this point in the game. This doesn't work. We're going to go ahead and say this only has one network interface, so we're going to say no. And this, again, is a work in progress. So this up here is the actual JSON that is generated from your responses. So now we have a host. Let's see. How about list, right? So we'll say 5. And we see fake host. And this is the ID that's generated, right? So, and that's a hash that includes information from that JSON object and a Unix timestamp. So I just copied that, and I'm going to display the details for that host, and it's going to ask for the ID, so I'll just paste that in there. And there's no pagination or anything like that, unfortunately. And yeah, I'm doing this in screen, which is unfortunate. Oh God, I can't remember how to scroll in screen. But anyway, it prints out all the information, and you can see up here where it says key HW. So that's the hardware block, which is a list, and then under that it says item 0. So that's the first item in the list. If there were multiple items, it would increment item 1, item 2, item 3. And that's based strictly off the index in the list. And the same thing goes here for the network interface. So key, net interface, item 0, and then these are the attributes in that item. Let's see. That's probably going to barf. Yep. All right. So let's try modifying the host. So we'll do that. We still have the ID in the buffer, so we'll just go ahead and say that. So here's this is something that I'm actually kind of satisfied with and pleased with as far as my own like I worked out how to do this in a pretty abstract way. But basically what it is you get the list of things that you can modify. Let's say we want to modify the asset tag. So we'll say we'll say asset 00002, right? I put an extra T in there. Let's do that again. So the current value is assets t. So we'll say asset 1, 2, 3, 4, 2. Okay, or enter to finish, right? So now it moves on to the next section, OS, right? And there's the values in there. There's nothing to change that there. Hardware item 0. Nothing to change there. Network interface item 0. Nothing to change there. So we're done. Now, here's the full Monty, the Big Lebowski, the Grand Wazoo. Let's print a label for the thing that we just edited. And up here, this is the text that you would print for the label. There's an extra step involved. Basically, as things exist right now, basically I have to log into the well, I either have to log in directly, which is the way I've been doing it, or I could copy it out to a text file locally on this machine and then SCP it over to the machine that that the label printer's hanging off of, and then LPR the text file with a couple of extra attributes. One is to rotate the document 90 degrees, and the other is to select the queue that the thing is going to. But ultimately, the goal would be to be able to say, to set a printer up in the configuration for this application and just say, send it to the printer. So when you click print, it just sends it there. That's not in there right now, but this label includes the host name, the function, whether or not it's a VM, the ID, so you can readily identify it in the system, the model, the serial number. The thinking there is, like, the model should be the model that you would readily identify it as, and the serial number would be the serial number. But do you need the manufacturer on the label? Arguably no. You should be able to see from all the branding all over the machine that it's a Dell or a HP or a Lenovo or whatever. And then you can see N0, the label will contain up to 2 network interfaces, the first 2. And if there isn't a second network interface, then the headings, the labels are included, but not the values. And that is basically what this is doing. So, so that's the functionality of the thing. Now, I readily grant If you have more than a screen full of hosts in your inventory, then it's going to fly off the top, and that'll make you sad. Clearly, if you're using screen, scrolling up and down, there's a way to do it. I don't remember how to do it off the top of my head, and I'm not going to waste your time having you watch me read a man page. So, but suffice to say, it's a little clunky, and I could do pagination. I just haven't gotten there yet. And the printing, directly sending the thing to a printer, as opposed to doing this nonsense with it prints the text on the screen. You have to select, copy it, drop it into a text file that's on the machine that the printer lives on, and then send it out that way. It's coming. But so that's pretty much the deal there. That's what the program does. So let's take a couple of minutes to look at the code, because, maybe you're not doing a project exactly like this, but maybe you want to do something kind of like this that uses a lot of the same functionality. So everybody's a little different in terms of what IDEs they prefer. I use Geany, and one of the reasons why I use Geany is because it is language agnostic and it's platform agnostic. It's open source, and you can run it on Windows, you can run it on Mac, you can run it on Linux, and it doesn't care about what language you're using. So if you're doing C or Bash or JavaScript or Python or whatever, it seems to be really good about understanding indenting and bracketing and identifying classes and methods and all that kind of stuff. So it's not the super duper-est of IDEs out there, certainly. But considering that this is properly open source, it's properly platform agnostic, and it's properly language agnostic. And it's pretty lightweight. You don't have to have a super duper machine to run Geany. I run Geany on Raspberry Pis all the time. In fact, what you're seeing right now is Geany running on a Raspberry Pi. This is a Raspberry Pi 400, and it's pretty darn responsive. So what you're seeing here is the fold view in effect. All these classes are collapsed just to make it a little easier to navigate around. And here's some extra code that I was using when I was first starting writing this. But basically what this boils down to is there are two classes up here, and inv element is kind of the core class that allows you to set up an object that has attributes and has a few methods on it, and that becomes a core of the inventory collection, right? So an inventory collection is fairly simple. It basically allows you to set up a list of inventory elements with a couple of methods on it. Now, the init is fairly straightforward. It builds a couple of attributes for the object, and then it calls this late setup. So the idea here is that, like for instance, inv host is inheriting from inv element, right? Oops, I didn't want to click the plus. And there's almost nothing here. And the reason is because all of these methods are all that this class needs, right? With one exception, and that is late setup. And late setup, again, it's called in the init of the super, right? In the parent class, inv element. And late setup allows you to come in and do all these little tricks like specifying the field definitions, right? And identifying the ID field and setting a value for it. And that continues for the OS and the hardware unit, which is the individual piece of hardware, as we saw in the demonstration of the program, right? So this has the ID, the manufacturer, the model, version, serial, blah blah blah, and then InvHW is a collection of hardware units. And there's nothing that has to happen in late setup because it's just a list, and the methods that are there cover what it needs to do. And the same thing for network interfaces. So now an inventory item is a collection of a host, an OS, a hardware unit, and a network. I mean, an HW and a net interface, right? And this has got a couple of extra methods on it, but nothing big. And this is again just setting up the attribute types, right? And you'll notice here we're setting inv. These are the classes, right? That the values of these things are actual objects instantiated from the classes. And really, there's nothing terribly exciting here except get ID and get values, which just iterates over the objects, the values of the keys in the in a particular inventory unit, right? So, oops. Yeah, this mouse is a little fiddly. I apologize for that. So, for crying out loud. Then there's inventory, which again is a collection, and it's a collection of inventory items, right? And this obviously has a few more methods on it that are specific to the top level of the data structure, right? Late setup does a couple of things here. It creates an ID list, which just kind of simplifies doing operations, lookups of items, and an items dictionary. So the trick here is a typical collection only has a list of items, right? And the thing about a list is all the data is encapsulated within. If you're looking up something based on some value that's inside, it's kind of a pain in the neck because you basically have to iterate through the list and check the attribute to see if it has the value. Oh, it doesn't? Okay, move on. Check, see if the attribute's there, if the attribute has the desired value, blah, blah, blah. Pain in the neck. So one way to get around that is to store it as a dictionary instead. The thing about storing it as a dictionary, though, is when you're iterating over the content, it's kind of a pain in the neck because you sort of, like, the way that I would normally do that is to grab the list of keys, and then for each key, grab the content and then do the thing, which it's easier, particularly if you're looking for a key, a particular unique key, but it's got its own drawbacks. So having both there It's a little inefficient, but it works. And then Scooby Doo. Let's see. So create item. It's pretty straightforward. We actually don't use create item too much. Instead, we use load item. So create item is kind of deprecated at this stage, and load item is used instead. And you can hand in a dictionary that's got all the values in it in the correct structure, and then this will just iterate over the contents in there and populate an inventory item. And it's pretty straightforward. It just goes ahead and checks to see if the ID is already present. If it is, say no way. Otherwise, it just goes through and determines whether the child, whether the value for the current key is a dictionary or a list. And this very well may be pointless because as of right now, there's no separate handling between no differential handling between the value is of type dict or the value is of type list. There may be at some point in the future, so leaving this in place as it is gives me the option to do any kind of differential handling if needed. But and I was expecting there to be differential handling, and it turns out no, because I'm just the value the method set value is the same externally. The interface is the same for both the inventory element and inventory collection. So that's handy. And then it just does a little thing where it appends to the item list and it appends to the ID list, and then it does the little dictionary thing where it grabs the ID, uses that as the key, and puts the item object as the value. And that's it. It's pretty straightforward. Then we've got load items list. Oops. So load items list just iterates over a list of item dictionaries. Or item, well, actually, they're technically, yeah, they're dictionaries. And so it just calls load item for each item. Pretty straightforward. And this is basically what's used when we pull in a file, which will come up later. Dump, all this does is extract all of the values and return a big list, a Python list that has the dictionaries in it. And Scooby-Doo get item, right? This just just grabs the item and returns it. But in this case, the item also has all the code that's associated with it. So you can do the little operations where you're extracting values or setting values or whatever. Saves you a little grief. Let's see. Set item value. That I still haven't written because I haven't had a need to. There's ways around it that obviate the need for that code at this stage. So set item values. Again, we've got the differential handling for dictionaries and lists. But again, that seems to be unnecessary. The difference here, of course, is set item ID, category. Right. So set value is specifically doing a surgical update on a value in a like for instance, if all you were doing is updating the comment on the host, right? So let's see. Do we still have the thing in the buffer? We do. Okay. So this comment says, I have no comment at this time. If in fact all you were doing was trying to update this field, well, you could do that. And all you would do is pass in the category, the key, and the value. And huzzah, that works. In this case, you're basically just handing the whole dictionary of all the values and all the categories and all that other information. And you could have updated one of the fields, you could have updated all of them. And this will weed through that and update all the values based on the new values that you sent in. Not terribly exciting, but it's good in a situation of, like, if you're doing an API or something like that, and you're locally modifying the thing, and then you just want to send the packet back. You can definitely do that. And that's pretty much it. Let's see. Set item values. We just looked at that. Get item values. So this is, you give it an ID, it goes through and gets you a dictionary-ified version, right? Because all of the values of host and OS and so on are these objects, right? You can't just use regular data structure manipulation to get the values out of these. You actually have to say, give me the values, and then it returns the dictionary. So this does that work for you. And that's pretty much that. So that gets you all of the functionality and all the data structures for the inventory itself. You need to be able to load and save the inventory. So I created a separate class for this, and it's kind of simple. There isn't a whole lot going on here. There's load file to dictionary, so this executes, and actually I believe it puts out a list, not a dictionary. Well, it puts out whatever the data is stored, whatever structure or format it's stored in, that's what you get back. But this basically does the base64. In this particular implementation, the data is stored to the file in base64. It is a base64 encoding of a JSON, and the JSON is just an encoding of the data structure. So here what we're doing is we're opening the file as read binary, and this file path is provided as an argument. We read in the base64, and then we close the file. And if anything goes wrong, we say file sad, report the error. Otherwise, we decode the base64, and then we transform the JSON into a dictionary, and then we return the dictionary. That's it. And save file to save dict to file. That's the same thing in reverse. We take in a dictionary and a file name, and we open the file. We write out the base64 encoding, and if we have a problem, we say sad file and print the error. And that's pretty much it. Very straightforward. The inventory shell is where things get kind of interesting. And this is 350 lines of code. So string max, well, let's start with init, right? And it's kind of busy here. But basically, this actually is the definition for the menu. As you can see here, this is an example, right? So there's the name, there's the description, and then there's the exec. So what the exec is actually a reference to a method on this in this class. So this is in a list, so you can change the order of these menu items by just changing the order in which they're appended to the list. The numbers that appear in the menu, like, well, so these numbers that appear in the menu are just the indexes of the thing plus one. That's it. So there's a couple extra things in the init here. This hard-coded file, data file, and this is the load. So when first you start this, when first you instantiate this class, it goes ahead and opens the file. May do that a little differently later, but that's pretty much the way it works now. And this establishes an inventory for this shell, and this loads the data that we got from the file into that inventory. And then we create the menu, and then the way this is run right now, you manually kick off shell.main, right? So you instantiate inventory shell, and then you kick off main. Main is just a loop, and it doesn't do a whole lot that's terribly exciting. So we have a variable called self.run, and that's up in here, right? Self.run in init. While self.run is true, user choice equals self.display main menu, and then self.switchboard main menu user choice. That's it. There you may have noticed that over here there's an option quit 7, right? If we look at the switchboard, we can see how that's handled, right? So if the name of the menu choice is quit, then self.run equals false. Bam, done. This is the list of indexes on the menu that actually have exec values. And the idea here is just to opt in to executing a menu item. That may change once all the menu options are populated, but for now, I decided to do it this way. And so basically, if choice in is the index of a menu item that has a valid exec on it, then we just exec it. We reference the value of the exec key in the menu choice index of the menu options list, throw these parens on the end of it. It's a reference to a method, so we're just going to exec the method. And if none of these things match, then we just print the choice in and the name of the menu. And the idea there is just, oh, well, I don't recognize this thing, so here's where you put in. And that's pretty much it. So that's main. That is boring as all get out. But display menu is not too bad. As far as the code goes, it's not all that complicated. That prints the menu. That's it. Originally, I had included descriptions, the description field as well. I decided not to do that going forward. I may bring it back. I don't know. But as it is right now, the menu is much simpler to read, just like this. With the descriptions, basically, it was doing a new line and indenting a little bit and then putting the description. And it just made it harder to read. So we accept user input as part of the display menu. Where's the raw input? Oh, this should be a raw input, actually. Huh. All right. Well, anyway, we accept user input, and we check to make sure that it's an integer, right? If they put in F, we want to say, I don't know what that is. And then we do a bad range check, right? So the range shouldn't be lower than the lowest number in the option list, and it shouldn't be higher than the highest number in the option list. So we'll check that. And if, in fact, the thing is in the correct range, then we'll say, okay, input bad is false. And then we'll return the list index, which is the index of the choice, right? Which again is whatever the choice is minus 1. And that's it. So by defining the menu with the name, the description, and the executable, basically we can have that very compact and very simple piece of code. We can add menu items as we like. And there really isn't a whole lot more to do there. And then the response to the menu selection takes place in the switchboard. And again, as we saw, the switchboard is painfully simple. And could be simpler still, if in fact all these things were populated. And then we get into the actual code for doing the things. Like, for instance, add host. And this seems bulky, but it's actually not too bad. And there's ways that this could be made programmatically more simple in terms of like not having all these raw input statements and stuff like that. And doing that configuration in the init and all that. But this wasn't too terribly bad to write. Most of it is just direct raw inputs. But this one, ask yn, is a special kind of interrogation. And the idea there is we want to get back either a true or false. We don't want to count on the user. We want to get back a simple true-false, and we don't want to have to count on the user to type true with an uppercase T and all that kind of thing. So we'll just say Y or N, and we can accept uppercase Y or lowercase y, uppercase N or lowercase n. Everything else, we just say, I don't understand your input, try again. Now, this is the sort of a thing that would be used in a few places in the code, so there's no point in coding it over and over and over again. So there's a method, and the method is this. We basically say retval, return value, right, is none. None is in Python basically a null. It's a non-value value. It's a placeholder, right? While retval is none, we're going to ask for input with a question provided in the arguments, right? So you pass the question into ask.yn, it includes it here, and then tacks on yes, no. The return of the raw input goes into TMPV, temp value, right? If temp value is in this list of possible responses, uppercase y and lowercase y, then retval is true. If it's lowercase n or uppercase n, then retval is false. If it's neither of those four possible responses, then it says please limit response to y or n. And it just keeps going through this loop until we get a y or n back, and then we return true or false, right? So that's that. This is for the operating system thing. This is for the hardware. And this does a similar thing to the ask true false, right? We set a flag variable here, more HW, more hardware, right? And we set it to true. While more hardware is true, then we ask these questions, and then we append to the hardware key, the list that is the value for the hardware key. We append this dictionary that includes the user's responses. Then we ask, using ask.yn, we say, do you want to do another one? If they say no, fine. Then that false comes back, and we drop out of the loop. If not, then we continue with the loop. The same thing is done here, except that hardware requires you to do at least one, and the NIC does not. The NIC, you can say there are no NICs on this thing, and it says okay, fine. And then we do this little thing, if host ID equals none. Host ID will almost certainly be none because we've never asked for it here. So we basically just do this little trick where we say we go through the dictionary looking for a value, and the value that we're looking for is basically anything that has a length greater than 0. And then yeah, basically what we're doing is we're taking the value of that key, we're running it through this gen ID, which is local to the whatchamacallit, the shell, and getting back a string, right? If the length of that string is greater than 0, then we go ahead and set the ID to that. And otherwise, if host ID does have a value, then we're going to go ahead and put host ID, put it in the host/ID key in the dictionary, and then save it, right? We do a load item to get it into the data structure. Then we do a dump to pull the data structure out in its entirety, and then we save it. So this business here is not terribly sophisticated. I readily admit that. Detail host is pretty simple, as I recall, and basically it just goes through and does your differential handling for lists and dictionaries, and that's pretty much it. just prints the key value pairs. That's it. Nothing terribly exciting there. The modify host, on the other hand, is something I'm kind of proud of, actually. There's not a whole lot going on here, and part of the reason is that there are methods that are being called in the outside, in the greater class. But basically, we're just going through each of the top level keys in the inventory item, and we're making a determination as to whether it's a dictionary or a list. And if it's a dictionary, then we have an edit dictionary method that we call. If it's a list, then we know the next level down is all dictionaries. So we'll just call the list edit thing, and that basically just calls the dictionary edit thing repeatedly. And if the value is neither a dictionary nor a list, we don't know what the hell to do with it. So we're just going to say wrong type and exit. So here are the dict edit and list edit methods. And these are pretty compact, all things considered. And of course, one of the benefits of doing it this way is there's no, like, you can modify the list of fields that are contained in one of these dictionaries, and it just says, all right, sure, whatever. And there's a few things in here that well, all right. So let's kind of walk through it here. We're doing the more edit true, right? So this allows you to be in potentially an endless loop of just, yes, I want to edit some more. Yes, I want to edit some more. And basically what it does is it gets a list of the keys in the dictionary, and then it wants you to select which of the keys you want to edit. So that's this thing. Select an item to update or print. Hit enter to finish. And so that's kind of straightforward. If what the user puts in is nothing, like an empty string, then we're going to say more edit is fault and valid selection is true. Oops. Boy, I didn't want to do that. More edit is false and valid selection is true. Valid selection gets us out of the select loop, and more edit false gets us out of the edit loop. If you put in a value but the value is out of range, then it says out of range. Pretty straightforward. This just sets up the working key, the original value, and the original type. So there's a limited amount of validation here. The assumption here is that as you're starting to edit, the type that was originally there is the correct type. Now, I realize this could be a bad assumption, but it's something, to try and prevent you from trying to stuff a string into a Boolean or something like that, or a string into an integer or whatever. So that's what this is about. We're going to establish the original value. We're going to establish the original type, the type for the original value, and the key that we're working with. This does a little business for us because of the way JSON works in Python. When you import JSON, it takes all the strings and converts them to Unicode, which is terrible, and I do not recommend, but whatever. The problem is, if you're doing an edit using raw input, you have one of two things that you can do. You can either take the input from the user and re-encode it as Unicode, or go the other way and say, the original value was Unicode, okay, fine, we're going to convert it back to ASCII, and because that's what we're working with. And that's the direction I chose to go here. So valid val is another one of those loop flags. We're going to start with the assumption that the value provided is not correct. The value provided is not valid. Then we're going to ask for the input. We're going to do some evaluation on it. We have some special handling in the case that the original value is a Boolean, right? This goes back to the answer YN, or ask YN, where we don't want to trouble the user with having to know that they have to type in uppercase T true or uppercase F false. We want them to type in true or false. In this instance, we want them to type in true or false, but we're not going to worry about case. We're going to smash case to upper, and then if what they typed in can be evaluated as all uppercase true, then we're going to set the value to true. And if they typed in something that can, after being smashed upper, can be matched to all uppercase false, then we're going to return false. However, in the case that the type was not Boolean, then, I mean, this basically just is the we're looping again notification. You know, you should put in either true or false. That's it. Otherwise, we handle it as a bad type. We say, not a valid type, try again. That's it. We just iterate through the keys, doing this little loop. That's the dictionary edit. And list edit is, I believe, even simpler. Yeah. It just iterates over the list of dictionaries in the list and calls dictionary edit. So once you've iterated through the top level keys in modify host, the returned values of list edit and dict edit are the content of the dictionary or the list. So we just pack those back into the value in the top level dictionary, and then save, and we're done. Not too bad. Print label is the last thing in the shell, and this is kind of a cheat, because basically what I'd done is I'd written a method as part of this early coding effort, just to make sure that I could fit everything within the available text on the label. Where did I put that laptop? Gosh, I just had it here. So this label Hold on a second. Where are we? There we are. All right, so this label, as you can see, it looks like it's all fixed width. And it's actually 30 characters wide and 6 lines high. So basically, I had to do a little bit of, old school retro computing. How many characters wide and what can I fit in here and all this other kind of stuff. And so basically, I just had to hard set up how this thing would print. So that's what this Print QL 700 host dict thing is. Basically, we're just getting the values, and we're going to print. This is like a clip and save notification, right? And the rest of it is the QL 700 thing. And this is all pretty straightforward, right? We're just getting the values out of the inventory dictionary item, and we're doing some string max stuff. String max just is a slightly elaborate way of saying print this if it's more than so many characters, truncated at so many characters. Because if you, in here, right, when you do this braced subsection thing, the substring in Python will say, if you say trim it to 19 characters, the string you hand in is 17 characters, you're going to get a middle finger. It's just not going to work. So that's the idea here. We want to say if the length of the string is greater than max len in, then we do this thing. Otherwise, we just return the string we got. Let me just do one little thing here real quick. Doop-a-doop-a-doo. Okay. So, there's a couple other things I want to go over, but I need to take a quick bio break. So if you will be patient, I'll be back in a couple of minutes and we'll wrap this up. Cool. Thanks. And we're back. So, one last swig of coffee left. So, that is more or less the inventory thing that I've got at this stage. Let's do that. Yeah, okay. So, one of the questions that I have is there anything that you would like to see in an application like this? So, like, is this something that would interest you? Put it in the comments down below. I'm open to sharing this as an open source type of a project, but, you know, I don't know that I necessarily want to go through the trouble of setting up a GitHub and all that kind of stuff if nobody's interested. So, you know, if it's something you're interested in, put it in the comments. Let me see. Yeah. So, the other thing is, are you interested in other software development projects that I'm doing? I have two other things that I'm sort of actively working on. One is a food inventory project. Since we're in this period of human malware, and it's been going on for quite some time, I decided it would be a good idea, since storing food for long periods is kind of a thing, like stocking up on whatever, because going to the grocery store is a pain in the neck and all that. I decided it would be great to be able to keep track of what food we have and what the expiration dates are and when we got it and where it's located and all that kind of thing, because, you know, we ended up getting a second freezer in the basement, and you know, we got a bunch of shelves from IKEA to set up, you know, dry good pantries and all that kind of stuff. So I can do a stream on the food inventory. That's a web app, JavaScript in the browser and Python in the back end, and it does a similar storage model to what I showed you with the IT inventory thing. It's basically just a JSON flat file. It's not sophisticated from the standpoint of doing any kind of authentication or anything like that. You could do that. You could do, you know, like Apache Auth or something like that in front of it. But basically it'll run on a Raspberry, and I have it on a virtual machine on my big VM host. But you know, you could very easily run it on a Raspberry and it would be just fine. And you know, it runs in the browser, and so I'd be happy to do a stream on that if you're interested. Put it in the comments. The other kind of big software development project that I've been working on, and I alluded to it earlier with my throwaway laptop, is a screenplay editing tool. And part of the thing for me was I wanted to see if I could do it, right? It's kind of an autodidactic exercise. Years ago, 2009, I started doing a web show called News Undies, all the news that shouldn't be news. It's another channel that I have on YouTube. And basically it was kind of a one-man band version of The Daily Show, you know, looking at actual news stories and doing comedic commentary on the news. And, you know, that was an autodidactic exercise in television production, basically. So I had written a script editing tool for that, and it was a web-based thing, and it was written in Bash. It was a Bash CGI script, which, whenever I mention that to people who actually write software semi-professionally, or, you know, advanced amateurs, the skeptical eyebrow just goes all the way back. But yeah, it had a MySQL database backend, and it leveraged ImageMagick primarily, and a few other Unix tools, common Unix tools, for text processing. But yeah, I wrote that, but it was a very narrow and very tightly focused tool that was oriented toward the format of the News Undies show and what pre-production materials, so what assets were needed for News Undies. So that was great for News Undies, but for doing something more general like a stage play or a screenplay, it really wasn't suited for it. Screenplay formatting is very specific about like how you handle page breaks and where different pieces of information go and all this other kind of stuff. So to rewrite that tool to do this other thing that I was interested in doing wasn't going to work. So I decided to start from scratch and build a data model and build a web app to create and edit screenplays. And the idea, the kind of conceptual structure of it is you start with a production company. That's like the top level of the data structure. And then within that, you have a show. And then for a show, you can have one or more episodes, right? So if you were going to do a movie, like a standalone movie, you would first have to have a production company, and then you would have a show, which would be the production, and then you'd have one episode. And then you just start writing. You just start creating dialogue and descriptions and camera directions and all these other kinds of things. But the idea is I wanted to be able to say, okay, I've got this larger set of data from which some of those elements would be included in a script that you would hand to the actors. Some other elements from that data set would be given to the DP, for example, the director of photography, or to the sound editor, or to the property master, or to the set builders, or whatever. Any kind of like practical effects things, or, and so you could have one master set of data that you could use to keep all that information together and in the correct order and all that, but just render it differently for the different targets. So that was kind of the goal there. And that is at a fairly good level of viability. I've been in a couple of plays, 5, I think, community theater productions. And the last 2 plays that I was in, I used this tool to type in the script as it came, right? And whatever notes that the director gave us in rehearsal, I went ahead and added them into the script so that, because sometimes they'll change dialogue for some reason, like let's just say for the sake of argument that it's a family friendly production of Wait Until Dark, or something like that, and you want to remove some offensive word or something like that. the script that you get from the publisher doesn't have a lot of room in it for notes. And so basically you have to have a notebook on the side that you're just scribbling your notes in, and it's a nightmare. And it's so much easier to be able to say, okay, I have a printed copy of the script here, and I can leaf through it, and I've got the notes in it. And if I have to add any other notes, I can add them, I can write them in, and then update the database at a later time. But anyway, that's another project I'm working on, and if you'd be interested in doing a walkthrough of that, it's quite a bit bigger than this IT inventory thing, in terms of code and whatnot. But it's again, it's a MySQL backed system, so it's MySQL, a Flask API, and then a Flask and Python API, and then there's the JavaScript in the browser. And yeah, so those are the two other big software projects that I have going on. If you're interested in seeing any of that as a like a walkthrough stream, put it in the comments down below. All right, so we've been at this for about an hour and a half. I think that's about all I wanted to say about the IT inventory thing at this stage. Development will continue, and if you have any questions or comments on it, suggestions, whatever, or if you're interested in seeing it as an open source project, please put it in the comments. If you enjoy the content that I've done so far and would like to see more, please subscribe. If you like this video, please give it a thumbs up. If you don't like it, give it a thumbs down. And I think that's about it. Tell your friends. There's no merch. There's no Patreon. So no sponsors. So we get to skip all that. And I think that's about it. So with that, I would like to thank you all for watching. And again, any questions, comments, whatever, put them in the comments below. Any suggestions, put them down there. Please subscribe, thumbs up, thumbs down if you liked it or didn't. Also, Ribbit Nerding on Facebook. Intermediate updates go there. Also, ribbitnerding.net. Or ribbitmedia.net, sorry. Is a relaunch of a website for my various activities. So if you're curious, check it out. It's a Ribbit with 3 B's, nerding with an E, .net. And, I'm sorry, Ribbit Media, Ribbit with 3 B's, .net. Yeah. Anyway, thanks for watching. And, keep the rubber side down and the shiny side up or something like that. I don't know. Thanks for watching. Catch you later.